See if it's streaming. So I decided to go back and finish, not finish, but continue to study recursion, to try to see if I can understand better how the logic that I'm using here works, because I think that I build things the wrong way on this one and I want to fix this one. I want to finish this thing first before I move on to creating the website. And I figured out what was wrong on the site. It was that there's two emit functions and I was using one that is not from the socket. And that's the problem. That's the reason why it wasn't emitting for the website. But then once I changed to use the one that the socket has, it started getting the data. So I think I can build the website, and I also was looking at the Viz project as well. So I think that I will be able to do that, but I think it's better to just go back and try to finish the other project first, because that's like, it makes more sense. So what I'm going to do here is to try to change the way that I'm getting the information, or change the way that I'm putting the information here, put more information here by getting the global and local variables on these nodes and try to analyze. And I also think I'm gonna build another script now. I also had to fix this again because for some reason it went back to the way that it was before. So I was thinking about whether or not to do a pull request or something like that, but I think I just don't have enough time to do this kind of things right now. I want to finish the other one first. I'm gonna stay here for 1.5 hours, and I might not be able to stay for 1.5 hours because I have a massive headache. So yeah, but I'm gonna try. I think I'm gonna put some music for myself in the background. And here I was on this project here, I erased the resetting of the variables. The reason why I think that I thought about this the wrong way is because I'm resetting, the whole resetting the variables thing fucks up everything else. And this is very complicated as well because I have to update a bunch of stuff. So I think what I'm gonna try to do is do the simplest way I can first. And then I see how to restructure everything. It's gonna be a lot of work. So I think on this file, I'm gonna do like the simplest thing that I can do first, which is just to create a function that loops over. And then I'm gonna put that one on the stack trace. And I think, let me see. We can do an enumerate here. And then gets change some item. Let me think. Oh yeah, it has to be act because I want to differentiate. Yeah, so I think I'll do this one. And the thing is, I think I'm gonna do another one there. And maybe I'll remove all of these variables here and just leave like one of them. I'm gonna keep it very simple because I just want to understand the logic. What I want to know is how the flow works with the recursion. That's what confuses me a lot. Because for building the lines, so like I have the data structure of all possible lines, and then each one is a level of the tree. That's the way that I'm thinking about it. So I need to emulate that in the simplest way as possible. So I have this data structure here, and then each one is a level alternating between players, each one of the lists. And then for each list, there's these possible actions. So what I want to do is navigate through the levels by going back and forth between players, and at the same time navigate through all of the possible actions. And the way that I thought about this is by using the recursion in the loop, that each level of the recursion, each time I do the recursion, I loop through the actions. But this is confusing because I don't know if it is like, how does it look like at the end of the thing? And that's why it's hard. So maybe I can copy this stuff here, there, and then just leave one level. And also at the same time that I do this, I have to change everything else as well. In the global level. What's wrong with this? First, let me remove all of this. I think I'll leave just true like this and try to do one level only. So I need to put one more here. Maybe I'll remove the... Just keep hero and villains. Yeah, I want to create a function that uses like a simplified version of the logic that I want to do. So also here, let's hard code this. Like, what makes things a lot more difficult is that you have to think about all the possible ways that each thing, the heuristics for what is going to happen after each bet or each action based on this treat. And think about the recursion and the loop as well. This is very confusing. But in this case, I wouldn't use possible actions there. I'm gonna remove this. And I have to return something as well so that it works on the trace. I think I'm just gonna remove everything and think about it again. So if streets, let me see the way that I did here and just try to do similar. The issue is that also I'm thinking about changing everything that I did here as well with the functions, because I'm calling this function outside. This might not be the best way, but it was the only way that I could think for the global variables. I think it would work if I didn't have to reset them. So the key issue I think is that I have to reset them. So every time that it reaches the base case, the way that I was thinking, I would like get the line. Maybe I can do that. Oh no, but the issue is back. I can't really do that because it depends. Each line depends on the pots and the calculations that happen on the line. That's the problem, because when it reaches the base case, then I have to reset. But then it's like it goes back, and then once it goes to the other base case from the parent node, it has the calculations messed up. That's the problem because of the global variables. So let me, as here, separated by player, and I put it to player there. And then I separated by street, I think. I think I'm also gonna close all the other files because I already fixed what I had to fix. Oh, the other thing that I figured out is that you can just, it's very easy to just call the event here to join the room. And then once you join the room, you can send the messages for specific rooms. So to disconnect here. Yeah, separated by player first and then street, I think. But the thing is, like, do I need to put this if I only have? Oh, I think that's fine. I'm gonna do like this for now, because I'm gonna see how difficult the graph gets to understand first, and then if I want, I increase by street, or I want to try to do the simplest thing possible first, so I can understand. And this is the part that it gets tricky, I think. So I think the best way to do it probably is different than the way that I'm doing now, which is just to create the structure of the tree first. And then once I have the structure, then I create another function that navigates through the structure and adds the informations of the nodes. To just create the tree of the lines, all possible lines first. And then we forget about the calculation. That might be the way to go. Because that way, then you can traverse the thing. But the issue is that if I do it like that, then I have to think about either I'm gonna have to create a different, like another node, but it doesn't feel right to create another node. That's the problem. Because then I can't, like, how I'm gonna save the structure of the tree. That's the problem. I can create based on the node ID, I think. Maybe that's the way. So first I just create a dictionary or nested dictionaries, which would be the tree with the node IDs, and then from that tree I create the other one. That is more complicated, because then I can do the calculations, because then I think I don't, but I think even if I do like that, it's probably gonna go into the same problem, because it's, for traversing the tree, it's probably gonna be better to create a recursive algorithm. And then if I do that, I'm gonna have to change the variables anyway. That's the thing. So here I also have to put another condition for a stack, I think. Let me see how I did here. And here I'm not using the function, I'm using somewhere else. I'm using from the class. So this is gonna be a global variable. Effective. No, this is gonna be, let's say 2500, because this is the effective stack. I think I won't bother with the. I'm not gonna put anything on the return. I think first I'm gonna use the debug here to step through, to understand how it's gonna go over. Or maybe I'll create a visualization, then I step through, and then I go back and forth between the debug and the visualization. Yeah, so here I think it's gonna be the same thing. And then the only thing that changes. Yeah, so I need the streets, the counts. Oh, do I need the counts? I think I don't need the counts. Yeah, now I need to think about a calculation that makes sense for the bets here and the thing. Like the simplest calculation that I can think of. It's just gonna be like that number divided by 100 times the stack. And because this is basically what I'm doing on the other one, I think. Or maybe it's plus equals. Which can be another issue. Let's see if I action, flop, streets, no action, current player. Let's put 0. And so here I need to think about the issue is that I have to think about the lines and the when it's gonna be like the end of a line. But I think I can put something simple here. Like if line something like that. Let me think. So pass the action, pass the player, pass the streets. Then it goes here, goes here, goes here. And then in the first actions, because I'm passing the global bats, these actions here, I think I'm gonna remove. I think I'm gonna leave it like this. Maybe remove this true here. The thing is, I'm not changing anything here besides the stack. So I need to append to the list. It's difficult because there's a lot of things to think about, like that I can change. And I'm trying to think which one I'm gonna analyze first. I need to think about the main thing that I'm trying to understand here, which is the way that the recursion and the loops are gonna change the global variables. I think that's the way. And not only that, I'm trying to think about like how I'm gonna fix the other algorithm based on that. And how to create the structure of all possible lines by navigating back and forth between these two data structures through using recursion and then using the loops to navigate horizontally here. So the recursion should go back and forth between the two. The loops should go into all possibilities of what can happen between this navigation. I think that I'm gonna run like this. Maybe I'll put here. I guess here. One thing that annoys me about debuggers is that you can't go back. At least I don't know how to go back. Like once you stop, then you can go back. Sometimes it's annoying. And it's gonna go here, here. So it's probably because of the global variable. So let me do the global thing. I didn't have to do this on the other one because I'm using the class, so. Yeah, now it should work, I think. Well, let me think about this going over my head first. So I pass the player, which is the hero on the streets. Then it's gonna hit this condition, and then it's gonna loop here, and then call recursively. So what I imagine that should happen is that the action gets. That's another question, is whether or not to append. I think I have to append here before the recursive call. Because in the actual algorithm, what I wanted to do is to have the previous actions that were made each time on the iteration, so I know how to code the logic for establishing what kind of line is going to be. Because some lines, like donking, depends on the previous actions, and also for the calculation of the re-raising, you need to know what actions happened before the current action. So I'm appending to this list what would be the action that is happening now. Then I'm increasing the stack by whatever amount here, which is just a simple example. Because after each bat, the pot increases. So if the current bat is greater or equal than the pot, it should return to stop the line. And then I call this recursively. So what I imagine happens is the act here is gonna be this thing here. And then it's gonna call recursively with that thing. And then once it calls recursively, it's gonna go here. But the issue is, and that's the challenging part, is when it reaches the base case. Because when it reaches the base case, what does it happen? Like, it's gonna pop the thing from the stack with the return statement. And then it's gonna go back all the way back until the previous Yeah, and this is the part that I don't know. Like, how does it decide what is the points that goes back to? Because it got really complicated. Like if you have a bunch of different calls here. Because on the second call, it's gonna hit this thing, and then it's gonna start this loop here. So like these loops are going simultaneously. And this obviously here is not representing like the way that it would be on the other one, because this is not taking into consideration the logic. But in the other one, I put the logic of like after a bet, what kind of decisions the other player can have, and then this is supposed to be the next level of decisions, let's say. So we would go from one decision to the other decision, and then starts looping here. And from this goes back to the function to get the other next level. And the thing that's very confusing is like what is going to happen with all the loops. That's the problem, because once it reaches the base case, it goes back. So what happens with the execution of the... I think it uses the return statement to keep going on the execution of the loop from whatever points. But the thing is, I'm not using the return statements for anything else, like for anything, for calculating anything. Just using it to stop the function. Yeah, so. And it's kind of hard to think about exactly like what is the best way to clarify this. I think that, like, from the stuff that I've seen people talk about, but they don't really explain how, like, this thing here, unless I don't understand really well, like, what they're doing. I have to do the global bats here as well. And this is something that is concerning because it might fuck up, but I think it will be the same. Because obviously I'm doing it in a different way on the other one. Oh, forgot. And I stop this here. Probably should put the street here. Maximum recursion depth. So it's probably something with the return, because I'm causing an infinite loop here. It's probably because I'm not stopping when there is a... This is the stuff about the lines that is complicated to take into account. When it takes a bath there. And the thing is... I think I'm gonna try again, just stepping into the thing. Like I think like this is the thing, intuitively I understand, and that's the problem, because intuitively I get it, I think, but I don't know why I get it, if that makes sense. That's the problem, I think. I don't really understand it really well. Because here, for example, I think the issue why is giving an infinite loops because I don't have any stop function here to stop the line, let's say. Except when it is a fold or an action, or the action gets greater than here. But then, like, because I don't have any condition here on this one, I think it goes in an infinite loop. But I don't understand really well, like, why this happen. Why does that happen? I need to step into. Maybe should always be using this one. Yeah, so far is what I'm thinking about. Where can I see the variables? I think here. Yeah. Oh, stack. This is what I'm mean. This is why I think that the graph would be useful. It's very hard to think about it by following through here. The thing that's weird here is that, oh, it's because of the condition, the way that I did the condition. I should put if the stack is greater than or equal to a number. That's why it's not stopping. Because I'm increasing the stack, but the actions are always gonna be like a low number. Yeah, this is the other way that because I don't have a pot here. That's the thing. So I confuse the action with the pot. It is another problem that you don't have. I think I'm gonna put 1000. That I don't have the. I think it is another problem that I don't have anything stopping the line on the other ones. But I think that this should solve there. I don't like this. Pots. I'm gonna stop this and do it again because let me run this first. The thing is I can't run like this because it goes to this file where the maybe I'll stop running the server. Just run from here. Where is this? Yeah, it's because I don't have the condition there. I'm gonna put the same condition here. Oh, actually, it must be the act, obviously. Well, I guess it's because I'm calling before. So if acts. You can just do the difference. I should probably do type. I'll do type different than string. Because it can be app as well, but it's not a big deal. Yeah, so now it runs, I think. So let's see. Let's watch the globals. So what I'm looking is the sum list here. And puts 32 there. Yeah, but just like this is not gonna be enough. Like, that's the problem, because it's hard to know like what happens on the previous ones. But let's go until it reaches the return, the base case. Yeah, it returns and now goes back to the loop. Yeah, I think I'm gonna have to try with the visualization. I think I put instead of a function as well, the other one. Here is inside of the DFS, so I think it's the same thing. Oh, now maybe it fucks up because of these events. Yeah, so I'm gonna disconnect, or let me think. I think I'm just gonna comment everything out. It's because I'm running on the wrong directory. I think now it worked. Yeah, so now I have to put, like, this is the question, how do I put the information here? The thing is that I'm not sure if I can, like, if it's gonna be useful unless I do the whole thing. That's the problem. Because ideally I would be able to step through this thing here while I go like debug there while I see the visualization. But maybe only by putting the variables is gonna be enough. The thing is that I might also have to change here, because that's not exactly what I want. But then it's difficult to think about, because what I want to know is, I think, when it is going back on the execution. But if I do it like this, it only shows the when it's going forward, and it doesn't show what happens when it goes back. I'm thinking now about how I can do it so that I can have like something similar to what the node ID would be. So I can put here so that it shows me like at each node it shows what the node ID would be. And then I can do it like that. So the label would be the node ID instead of the thing. I think that might be more useful, as that's essentially what I wanna see. Let's say that it starts at the root and then it goes to the bat. For example, it would be root plus bat. And then when it goes to the left, it's a check, and then it finishes there. I want to know what happens when it's going back and then going to the other line with the global variables. Yeah, so not what happens, but how to make it so that the challenge is how to make it so that you have the line only up until the point that it creates a bifurcation on decisions in the recursion. That's the challenge. So in that case, like if I have a situation where it goes like this, root bat check, and then it goes back to bat here, and then goes deeper into another line, let's say, for example. So it would go here, reach the base case, and then it would go back to this level, and then from this level, go to this one. The challenge is how to get the same structure up into this level here, the same global variables. So that from this point, it has access to the same thing that it had access when you did the bifurcation here, which I think it happens every time that you make a recursive call. So I think that the key might have to do something with keeping track of the variables up until the point every time there is a recursive call. But then, like, how does it work? And how do I clarify that? That's the question. How do I clarify what's going on? I mean, obviously, the first thing that I can try is just do the global variables thing on the graph. But maybe... So let me think about the node ID. I think I have to put the node ID logic here. Yeah, current node ID. And then at each time I need to call the node ID with the updated action. And then I need to return the current node ID. And then on the label I put the current node ID, maybe. And then later I will test. But I think that it's not gonna be resetting the variables here. That can't be the answer. So it's not gonna work if I have to reset everything here. I have to figure out a way to keep track, to use the same history, let's say, up until the bifurcation of each time. At each time. So that I can use the same history. But it's not only that, but it's also because that's where it gets complicated, because you can have multiple different histories at the same time if you're doing different recursions, I think, because each one can have its own bifurcation. That's the problem. Let's say if it goes here and then here it had another bifurcation. Like I not only need to keep track of the history up until this point and use that history for the other nodes. But for this bifurcation, I would need the history for up until this. So, like I'm thinking some caching mechanism. Like using a dictionary, like is the obvious thing that comes to mind. But then how to structure the dictionary? I think maybe using the dictionary, every time there is a recursive, you pass the node ID. But then the thing is, you would need all the information that it is required. Like I would have to store all the global variables up until that point, and then make the key value pairs being like the key is the node, and then the values are all the global variables that were used up until the point. And then I would need to think about how to get those global variables from the dictionary for the other nodes and put that logic on the recursion as well. So it sounds like too complicated. So I think that there must be a much better way that I'm not thinking about. And so what I was doing is the current node ID. Return current node ID. And the node ID only matters for the line. And the question is, how do I capture this on the set trace as well? Because I can capture the event. So I have to search for that as well. Yeah, but here I'm just popping the thing. Maybe I can just capture based on the global variables. But on the return I wouldn't catch. Now, obviously what I'm gonna do here is just do another string with the local variables, I think, and put as the label. Separate them by line, formatting the string, and put them as label for each node. But I'm thinking how to capture the thing here. Like the return. How to label the nodes differently. Oh, the other thing that I was thinking about doing and I ended up not doing, but I might do, to put the color variable here. That's one thing that I can do. And then once I get to this point, I change the color. I think I'm gonna do that now. But then the thing is, I can only change twice. That's the problem. Unless I think about a logic. Different logic. So let me think. So after each action on the recursive, before the recursive call, I have to pass the node ID and I have to add the action. Let me run again, run first. So it looks like it's running. So debug and then I'll be the, I think I'm gonna put the variables, build the visualization first and then put the variables. Where's the node ID? Max node ID. And so far it looks like it's working. And then returns. Now is the moment, I think. So when it returns, it goes back to the way that it was there. Like a previous stop. And then it continues the execution from that point. And now is on the other thing. So let me think. It's doing exactly what I thought it would do actually. The only problem is this thing of the bifurcation. So I think I have the correct intuition. What is happening. So every time there is a recursive call, it's gonna bifurcate into possibilities, and it's gonna explore the bifurcation until it gets through the base case, and then it pops everything up until the point that created the bifurcation, the last bifurcation, which may be another one if there are multiple recursive calls. That's where it gets complicated. Because if inside of this recursive call, I call this one, then there's a bifurcation, there's two bifurcations here. And then if it stops there, then it's gonna go back, but then only to the point of the first one to explore the other paths from the last bifurcation that happened, I think. And then once all the paths were explored from the bifurcation, then it reverts everything and goes back to the first one where it started. So the challenge is how to create something that's the best possible way to update the global variables based on the path, based on these bifurcations that happen. So that you always have the same history up until the point to use for every line, so we can update everything. That's the question. Now here is returning because it's reaching the... That's the problem, because now each time is gonna be... The pot's gonna be greater than the stack because it's a global variable and it's not being updated. So let me see if I put pot equals, let's see, 400 or something like that. What's gonna happen? And let's first run. Yeah, maximum recursion depth. Because now, well, let me think. Yeah, because if you have, and this is the stuff about the line, because you can have a situation that the recursive calls never get to this string here. So it goes on a cycle, because I'm not handling the other stuff. Like the other possible lines. On the other one, is always gonna get to that case, because depending on the way that the line goes, I know that it's gonna be the end of the line in the river, depending on the decisions. And I'm also putting the effective stack, which is supposed to be based on the line that is happening. So it wouldn't be like how would it go? How would I reset the pots? That's the question. So maybe instead of doing here in the base case, I have to do it before the recursive calls. The updating of the variables. But that wouldn't make sense, because then you would never reach, I think, the base case. That's the problem. So goes your pops back. I think I'm gonna do this thing here while I think about it. It's very hard to think about how to solve this. Because I think when you have the tree already, is a lot easier. Because the values would be already placed on the nodes. I think what I can do for now is just put the label here. Just change the label and see how the graph looks. I think I deleted that thing. No, just ask ChatGPT. I think it's on the frame. I have to find the thing again. Maybe just print here. I think it's frame globals or something like that. As I don't know. Maybe Zaf globals and F locals. It's because I didn't put here. Hmm. I think this one is correct. The issue is that the format's not very good. I think this is a dictionary. So I think I can just get the node IDs each time. And the node ID is gonna be local, so let's see. Hmm. The problem is that I need to. I think I'll just build the graph, or maybe I'll do this. Yeah, so the key... Oh, that's weird, because it should have the... Let me think. Why is not getting the value? Oh, I'm not printing. So dumb. Yeah, no, should. So it's weird that it says that it doesn't have the node ID. I forgot the name. Oh, so now it works. Maybe it's just because I was accessing with the dot notation. Yeah, so what I'm gonna do is just put this stuff here. And now you should create the graph with the labels as being the... But I should put the number as well. So it's doing current frame there. I guess... Because I also want to be able to know the order of the nodes. But now, why it's not working now? It's probably because of the way that I'm using here. And there we go. And then I use current label. I think I don't need to open because it's gonna open. Yeah, but now the issue is that I need more, I think. Root 0, 1. Yeah, so it is like the way that I was thinking. That it works. I think I'm gonna print the plots as well. Just gonna make a new line. I think for doing like this, I have to use the 3 things there. Like this. And here I put new line. And then here create the other. Maybe I should put the I first as well. Should put I and then the new line, and then put the rest of the stuff. And here I put the pots, I think. I think I'm looking at the wrong one. Yeah, so I think I have to see like with the easiest way possible. And I think that way is probably with the pots. So seeing how I can reset the pot so I have the same value. So here, like let's say the pot is 100 here. It's gonna be different on each time, but then, yeah, but the thing is I need one more level, I think, of recursion. Because this is too simple. It's not gonna allow me to see, because I need another one to see, like let's say this is 100 and 150 here. And then here would be different, but it would like, I need to know what calculation I'm making to increase each time. And I think I need to, instead of making based on the bets, I put a fixed amount there. That's a better thing to do. Because then I know, like, it's a lot easier to reason about what is happening. Let's put, and if I change the calculation to be a fixed amount, it's going to increase the size as well of the recursion. I think. Maybe let's put 300. So that way I'm gonna be able to think about how to change the pot or to structure the pot in a way that allows me to always have the same value from different bifurcations. Yeah, so this is the issue, because now I have to see what is the exact name there. It should be, no, it should be a global variable. That's the problem, I think. Yeah, there we go. Okay, now, yeah, it's like this because it's always hitting the base case only with the pots. It is a little bit confusing to see. Okay, so it starts at 1,000. And these are all the same except for this one. So why is this one different? This is the first one. So I guess it's different because of the way that it goes back. But the other ones should be different as well. I think it depends on the, because it's gonna change at each time there is a recursive call. So, and then from that point is using that value that you used on the first time, and that's the one that is gonna show here. So, like this is why here is a lot greater than here, because even though it's on a different level, because when it gets to this point, it already increased all the values for the pot at each iteration. And then this is using the global. So what I want to accomplish is, instead of having this value here, I reset the value in a way that it's always going to be from this node to this node. It's always going to be this value times plus the value that I put here, which I think is 300. And I think once I figure this out, then like it's gonna be very complicated. because the other one there's a lot more stuff involved as well. But at least I'm gonna have the framework, I think, because then it's just a matter of like figuring out of adding the other variables. Yeah, but first let me try to understand. So I'm increasing by 300 each time. So I want to understand. I think it's just because of the levels of the recursion. Because this is probably one level, is the first one out of these iterations. Yeah, this is the first one. Then it goes through this. So this is why this value is lower, because then when it goes back, it increases the value for the other ones, and like, but then why does it increase the value for? I think it's just because of the levels thing. Because this is reaching a new level, let's say, because it's going back from all of the other ones, and then it's going one level deeper again. So every time it goes a level deeper, it increases by 300, but it doesn't increase on the other ones because it's exploring on the same level. That's why. So the question is how to keep the same values, same global values for the levels. And it would be very helpful if I could do this in real time. Maybe I don't need I don't need to create the front end with Svelte. Maybe I can do it through the issue is that, like, I think it's better to figure this out like this first, even though it's not the best, because the other stuff is gonna take too much time. Like, I'm gonna have to figure out the physics engine and how it creates the canvas. I was looking into this today as well. Like, how it creates the graph, because I think that it creates from the Jinja template, but instead of doing that, I'll have to figure out how to create in real time. Like, every time that I put a node, I put the graph here. So I need to figure out how to create a canvas in real time. That's the problem. That's why I think I need to do it in the front end, because from Python, the only way is going to be using Jinja template, and then it doesn't work. So you need to have the information on the front end, I think. But then that's the problem, because then it gets into a bunch of different other stuff of how to update graphs in real time, and how does that work under the hood, the canvas, and everything like that. But I would say that this is very helpful, at least for now. Like, even just seeing the basic thing here, it's already much better than just looking at the function itself to understand what's going on. So let's go from 1 here, then 2, 3, 4, then 5 increases 1. Oh, but here it is. Oh no, yeah, because the first one increases, the other ones stay the same. But this calculation is also weird. Oh, I'm missing 6 because so here is weird because it's increasing 2 times, but all of these are on the same level. So why does it increase? I think it's because of the way that I'm doing the visualization there, because I'm putting the stack frame to be greater or equal to 2 to pop the items. And that's because if I don't do it like that, then it creates different graphs, because it pops everything out of the stack when it reaches the root. So it's creating the wrong visualization, let's say. Well, let me think. It reaches the base case and then goes back to this one and adds again. So what I need to think about how to capture is, like, maybe I can use the line thing. I need to add the line, I think, that it happens. Because Yeah, what I'm trying to capture is like being able to visualize where I'm at here in the code, but instead of in the code here, in the label. So I can visually see, let's say, like what is happening through the function. At what point I'm at. So I think the simplest way to do it is to add the line to the visualization, to the label here. And then I don't remember really well, but I think it's with F line or something like that. I need to look at the documentation. Because I'm pretty sure the frame has the line. Maybe I'll just try it out. I try like this, and then if it doesn't work, I'll search. Oh, line number. So maybe, hopefully this will help. I know it's a little bit different than it was before. So all these recursions are on line 20. Which is weird. Because so I guess it's because of the problem of the stack. Like this is not showing when it gets to the other point. That's the problem. Because once it reaches the stack there, it always stops. Let's see if I can show. I think I understand what is happening. Because it increases the pot, and once it gets to the size of the stack, it is always gonna be, let's see, line 20. Or maybe not, because yeah, so the line is the line from the function, so that's the problem. Because I'm only getting the frames. That's weird. Maybe I should print the event. Maybe I shouldn't print this return here as well. Shouldn't do the return here. I think I should print the events here to see if I'm getting the line numbers. The line events. But what is happening is always printing the line that the function is done, because this is the stack frame, I think. But there was a problem before where I did this function and I wasn't getting the other events and the return statements. But here I am getting the events. And it should be... Oh no, because... Well, let me think. Because I'm only appending the things when the event is a call. That's the problem. So the line is always going to be... It's not like it's not getting the other lines. It's always getting the line from the function call. But then shouldn't it have like the other lines where the function call exists as well? Like 41 and 51. That's the thing. Maybe it's because it only shows in the beginning. So I'm thinking now, like, if this is messing up the visualization. because if it only shows the function after it calls, there is a different visualization than if it shows every time, like all of the stacks, every time that it calls a function again, recursively. I'm probably gonna stop soon because it's almost 1 hour and a half. I'm probably gonna continue this next time anyway. Yeah, so it should be showing different things now, I think. Yeah, once it reaches the base case, it goes on the loop, continues on the loop. So I guess that's another thing that I was thinking about it in the wrong way. But it might be because of the other, like this is not, it's already on the base. I think that's the problem, the thing here. So the confusion that I'm talking about is that, like one way you can think about it is that once it goes back, once it reaches the base case, it's gonna go back and then go back from this point, let's say, because the last time that it stopped was a level before where there was a verification before. So it went through this recursive call and then it went through this, and then it reaches the base case when is going through this recursive. But then it goes back and back, and then it should continue from this point, let's say. But I think on this case, like it's not deep enough, so just one layer deep, let's say. So it continues the loop from this point because it is reaching the base case from this point. So it's like going on a loop. And I think that's why the graph is like this here. Because this is representing, these nodes are representing the loop. And then here, like that's the thing. And this is because of the way that I put the logic for the pot, I think. But I think that for each layer of loops, you should have this other structure here, because for each, so this is one of potential actions, I think, for a player. And these are the other actions, I think. But because the pot is already like very big, then it reaches the base case, and so each one of these should be a tree based on because they are based on the potential actions that you have there in the beginning, I think. So I think that the way that I did the algorithm is the correct way to do it, but the only issue is the global variables and the whole thing about reinitializing them and knowing where to keep track of each thing. But the weird thing to me here that I have to think more about it is the line, because it's always getting the 20, and I assume it's because it is the function call each time. So each time that it receives the stack on the other function on the set trace, it is receiving the stack frame from this function call here, which is in this line. So when I'm capturing the data, I'm only capturing on the call event. And whenever that happens, is the line is on the... So I think one way to... I would say actually, but now I think about it, it wouldn't work, but I was gonna say that one way is to change the line only when there is a line event, I think. Change the function line. That might be a way to, but I think it's not gonna work. So what I wanna be able to achieve here is to get these two lines here. I wanna associate the lines with the stack frames. So But the thing that is challenging is that I don't necessarily want to add more nodes, because that might fuck up the visualization, because it's gonna make the graph more complicated. So I think the best way is to change the labels, but what I want to visualize is the structure, exactly what I'm doing here, but then be able to see more information for each node that doesn't fuck up the structure of the thing. So to be able to get as close as possible, in the simplest way as possible, to navigate the code, to know whatever is happening here at each step, like to be able to visualize here as I look at the graph here. So almost like I was taking a snapshot of the code each time that I create a node here with all the information. And that way, like I'm gonna be able to have a bigger picture of what's going on simultaneously on all the lines. So ideally, I would be able to have here, like what was the last line, from where this node was called. So I think the line here has to be either one of these lines here, 41 or 51, because I want to distinguish the two recursive calls so I can understand more how the back and forth is happening. I guess that's where I'm trying to get at. It's trying to understand like how the combination of the loop and the recursive are happening on the structure here. And I think if I have the line, it's going to be easier to... Maybe I can figure out a way to change the colors as well, based on each function. Where was the recursive call? So I think the first thing that is coming to my mind is to change whenever there's a line event. Then I do this. First, I would have to put global. And maybe I'll do... But I think like the problem with this is that maybe it works. I'm not sure. So it's gonna show now the last point that it was, the last line that it was executed before the stack, I think. I think I'll do this one and then I'll stop. Yeah, now it works, I think. 41, 51, nice. So now I can see what is the recursive call. 29. Let's see, 29. Oh, it's because it's the base case. Interesting. So whenever there's a 29 or a different line, it means that is the place that is going back. I think 27 here. 29, 41, 41. Yeah, I'll think more about this. I'll probably continue to do this tomorrow, I think. And my priority now is to figure out the stuff that I talked about, which is to know how to change the global variables in a way that is going to allow me to keep the same information for each branch of the tree, so that I can create all the lines. I think that's the only thing that is left. And once I figure this out, it's going to be very complicated to finish the other algorithm, because there's a lot more global variables, and I also have to fix the calculation of the amounts, which is very complicated. But then I think once I have these two things, then I can finish the other algorithm. And I think that the priority for me now is to finish the other one first. But I still, like, because obviously if I can make this better, then it helps the other one as well. But I think that it's better to first finish the other one, because the other one is more helpful, I think. It's gonna help me play poker better, I think. So it should be a higher priority, I think. But then once I finish the poker, then I'll go back to this and I'll finish the side, or try to finish the side, depending on how hard it's gonna be. I think just displaying the visualization of WebSocket, I'm very close to already being able to do it. It doesn't look like it is that hard to. The hardest part comes on like trying to modify the Viz library, because then you have to understand all the physical simulations that they use there and the whole structure of the library. I think that's the part that it takes a very long time to figure out. So I think probably for the next couple of streams, I'm gonna fix this or study more the recursion, try to understand how to do that and solve the algorithm, and then go back and try to finish the poker software. And then once I have that, then maybe go back to finishing the